following function is continuous? We are recording, right? Right. Say hi, Harley.
Yeah.
All right. Where is it continuous? Okay. Well, sort of as a go-to rule, you want to assume everything's continuous everywhere, except where it's not. I'll say again, just assume that it's continuous everywhere, except where it's not. Okay? So then the question is, where is it not continuous? So
Where
maybe,
the denominator equals 0.
Where is it not continuous? And the answer, one of those possible answers, is when the denominator equals 0. Particularly in a rational function like this. If you have trig functions and stuff like that, you have asymptotes and things like that. This is a good one for this case. So we would assume, so when x squared minus 1 equals 0, your algebra's kicking in and you're thinking, I can factor that. I guess you don't have to. You could just say x squared equals 1. Rigel, you're thinking how to get rid of the x squared? Square root, right? Okay, I'm going to square root both sides. I'm going to pick on you, Rigel, here, since I know you're looking at us here. So, Rigel, what is the square root of 1? Nope, it is not I.
The square root of 1.
That's the square root of negative 1. Yeah. I don't think you're ever going to see that in this class. So just calm down. You only deal with real numbers. Somebody else want to play square root of 1?
1.
Partial credit.
Or negative 1.
Or negative 1. Okay? That's what will get you on this one. Okay? So remember, taking the square root of both sides, there it could be plus or minus. Okay? So like I said, when it asks when is it continuous, assume everywhere. Assume it's continuous everywhere except where it isn't. Kind of a funny way to think of it. But that would mean if it was continuous everywhere, that would mean all the way from negative infinity all the way to positive infinity. But we know now that it is discontinuous at x equals 1 and x equals negative 1. There's a hole right there. Okay? Maybe even asymptote. I don't know at this point. I don't really care. Negative 1 and positive 1. It's not continuous. Those are the breaks. So I need a way of making a list from all the numbers from negative infinity all the way up to negative 1. Okay? So they're recommending I use interval notation. So the way I do that is I do open parentheses, negative infinity, all the way up to negative 1. All right? I do not want to include negative 1. Does anybody know if I use parentheses or bracket? Parentheses for when I don't want to include it. Okay? And then also, do they give you the union option on those answer choices?
So.
They should. That's the most appropriate way. So, and then I want to union this region right in here. Absolutely, it's totally continuous between negative 1 and positive 1. So negative 1 to positive 1. I'm going to take care of all these numbers. Take care of these numbers. And then I want to take care of these numbers. So I write in a room here. Union from 1 to infinity. Remember with infinity and negative infinity, you're always using a parentheses rather than the bracket. You're never using the brackets with infinity. You're always using the parentheses. So, something, we may run into this down here. We may not. I have seen variations on this. Remember, just as a side note, anytime that you're dealing with a quadratic, if you can't do something nice like that, consider factoring, okay? Also consider the quadratic formula. So for instance, this one right here, if for whatever reason they had x squared minus 5x plus 4, and we were trying to find where that was equal to 0, okay? I've talked with several of you where you've tried to put that 4 over to the other side, and then have x squared minus 5x, and then you've tried to factor that x out, and then you have x minus 5. You know who I'm talking to if I've had that conversation with you. Okay? This is the wrong way of solving a quadratic equation. Okay? This would be the right way to solve a linear equation where you get one variable all to one side and you get all the numbers to the other side. But with a quadratic equation, your ways of solving that are really limited to number 1, factoring, number 2, graphing it and finding the zeros, number 3, the quadratic formula. And am I correct? You've had to use that to solve some of those homework problems. So if you don't remember the quadratic formula, here it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you want at some point to review over that, I can talk to you individually or after we get a few more of these problems done. There is a fourth option for solving quadratics. It's hardly ever available, but it worked in this case, and that is you can just get, if there's just an x squared term, isolating that x squared term. That worked out well for us in this, but may not always happen. All right, let's get on to more calculus. Yes. Sure. Let me write you that. Alright. Number 3 says evaluate the limit of square root of x minus 10 as x approaches 10 from the right. Explain why this limit doesn't exist, the one with the negative, and then those are pretty much your options, okay? Now I'm pretty sure he's going to allow you access to a graphing calculator on the test, right? Okay, so this is going to be super easy to evaluate these limits, okay? You're just going to plug in this function and see what happens as x is getting closer and closer to 10, okay? You can graph it and see it. You can also table it and start plugging in some values, okay? So I've got y equals square root x minus 10. And so I want to see what's happening. Remember that plus means from the right. So here's my x values, here's my y values. I want to see as x is approaching 10. So keying in this way, say like, not 9, it's smaller than 10. Maybe 11, 10.5, 10.1, 10.01. Do you all remember how to manually enter in values into the table?
Yeah, like tables, change the anything to add whatever.
For those of you that weren't in my pre-calc class, Rigel, you might not know this. If you go to your y equals and type in square root x minus 10, and that's all nice and happy. The calculator, whenever you table it, it's not going to give you these values. But you can make it give you those values with a little bit of calculator trickery. So hit the second button and then go to where it says table set. It stands for table setup. You'll see a table and a delta table, table start. What we're going to change is we're going to change that independent variable. Right now it's auto generating, which means we're going to go over to ask. So it's just going to ask you for those values. Then you can go to table. And then you can type in 11 and hit enter, and Roger, what do you get? When you, yeah. I agree. Keep working with me here, Rigel. 10.5.
you want me to go back and type in?
I want you, you're still looking at the table.
It just gives me 10 and 11. I can't figure it out.
Let me see what I can do for you. Let's go back to the setup. No, I don't want you to do that delta table. Just you do that whatever. Okay, let's go to the table. It's so weird that it auto-generated this stuff. Sorry. Table setup. Table start. I'm gonna say the table start 1 and 2. Independent task. Everyone's weird. Oh, this is weird. Yeah. Somebody else already typed in. So it should come over with that. You type in 11. Enter. This is what mine's looking like. Because you don't have, you type in an equation. Let's type in an equation. Square root of x minus 10.
One talking about his angels getting.
Basically,
So type in, alright, now type in, 10.5.
I could do this, but maybe
Yeah.
it would really help
See?
someone help me and say that they were fine. That's what she's doing.
Alright, I don't care about all that stuff. So
Jane, she's talking about that whatever it was, she
Let's
was
go to
like,
mine.
really bad idea, so she's like, no, don't do it.
So let's type in
Even though
11.
I got frustrated, but.
Enter. 10.5. Okay, so you said 0.707? I like that, actually, seems familiar. 10.1?
0.316.
10.01?
Oh yeah, 0.1.
Definitely seems to be approaching some value, right? In fact, can we just plug in 10?
Yeah.
We should have just done that from the beginning. You just plug it, if you just plug it in, then just plug it in, okay? That's great, but I wanted to show you that little tool so you're not having to type in the square root of 10.5 minus 10. Square root of 10. You're gonna waste your time, okay? Don't waste your time if you got a calculator that's gonna do that. So, there you go, it's 0. From the right, it's equal to 0. Then they want us to say, explain why, oh, sorry. They have an option right here, 0. Explain why the limit of the square root of x minus 10 doesn't exist. Oh, sorry, as x approaches 10 from the left. Okay, well, I'm not sure why that would happen. Maybe I'll just plug in some values here. So x and y. Let's see what happens as I approach it from the left. So I'll say 9, 9.5, 9.9, 9.99. So kind of get closer there. So what happens if you type in 9?
I got an error.
I did too. What about 9.5? It's a pretty big hole. What about 9.9?
You can't take the square root of it.
Ding, ding, ding. She is correct. She's saying you can't take the square root of a negative number. Alright, so I'm actually gonna, so I'm getting error. Yeah, so let's see, so let's just plug it in and see what happens. 9 minus 10 is gonna make a liar out of me. That's I. I said there's no I's in this class. There's only a we. So anyway, yeah, that's why it's a non-real answer. So we can A, the limit does not exist because square root of x minus 10 is not defined for x less than 10. That seems like a pretty good answer. This one, it does not exist because it is defined for x greater than 10. Well, just because it's defined by x greater than 10, that's not the situation we're dealing with. We're dealing with less than 10. This one, it does not exist because x minus 10 for x minus 10 is defined for x less than 10. We've just determined that it is not defined for x less than 10, and it does not exist because square root of x minus 10 is not defined for x greater than 10. Also false, it totally exists for x greater than 10. I agree with you, Jesse. A does look like a really good answer. Any questions on that? Alright. I really wish I could give you some theory up here that would sort of help out with this, but maybe just sort of going through the discussion, you kind of pick up on the theory yourself. Yes?
Back to the calculator, do I have to put 1 every time? Because you change the numbers for table start to 1 and table to 1.
No, the table start, those items right there are whenever you have it on the auto setting. Have you ever wondered, how does it know when I go to the table to start at like 0? Why doesn't it start at like 50 or 200? You can change that. If you change that table start to 200, and you change the triangle table, which means for delta, you change the delta table to like, I don't know, 3, then that means it's gonna, whenever we go on auto, it's going to start your table at x equals 200, and it's gonna go up by 3s. So change it to auto, so go ahead, give it a shot there, change it to 203, and then go auto, and you'll see what happens. That's helpful if you want to look up a table with certain discrete values or whatever, maybe counting up by 5s or by 10s or something like that. Leave it like that, it'll mess up my pre-calc students. Flip. It'd be great. Oh my gosh, this one looks pretty crazy. Alright. Number 4. Determine the limit of f of x as x approaches infinity and the limit of f of x as x approaches negative infinity for the following function. Then give the horizontal asymptotes of f, if any. Oh, you're gonna love this one. Okay? So this is we want to figure out what happens as it approaches infinity. You've got a couple of different options in solving limit problems. Okay? Technically, you've got 3 or maybe 4 tools for solving limits. I will write this one up on the board since this is a good. So Ryan, I'm just gonna keep picking on you. If that's all right. Maybe Alex too. He's over there. He's listening. Okay. All right. The question is, how can I solve a limit problem? What are my tools? Alex, what was the mechanism that we just used a moment ago? A table, that's right. You can table it.
Did you say one of those factors?
That's for solving a quadratic equation. This is for evaluating a limit problem. Anybody else volunteers? The easiest way of solving a limit?
Plug in the number.
Okay, yeah, plug it in. I'll write, the technical term for that is direct substitution, but I'll write both of those. Direct substitution means plug the number into the function.
This is the squeeze theorem.
Yes. The squeeze theorem is a way of, yep. It is a rather unorthodox, when I say not unorthodox, just sort of an unusual, sort of a random beast, this squeeze theorem. The only time I've ever seen the squeeze theorem used is determining the limit of sine x over x as x approaches 0. It's the only time I've ever seen, and cosine x minus 1 over x. That's the only time I've ever seen the squeeze theorem used in any of the calculus books. Okay? So, we can talk about the squeeze theorem later if we come across a problem or if you're curious. Let's keep going. What's another easy way of solving a limit problem? What's that?
Putting it in the calculator.
And graphing it. Yeah, just graph it. Those are all ways of solving. Like I said, I would put squeeze theorem as a distant fourth. But graphing it, direct substitution, great way. Table is a great way. It's going to work every time. Direct substitution will not work every time. Table is going to work every single time. You've got to figure out what's going on with that. Direct substitution, sometimes. The squeeze theorem is very rare. Graph it, that can be dangerous if there's a hole, okay? Or if there's something else going on.
Isn't there like a set of rules where you look at the x, and if it's x to the fifth, since the 5 is greater than the 1 and x1, like it'll be like 0 or something like that?
Yeah. That's other tools. Say other tools. Like that thing. Now that's dealing with this one as x approaches infinity. So, yeah, absolutely. We're wanting to figure out. I'll write it down a little bit more explicitly here. What's the limit as x approaches infinity of 3x plus 1 over 4x to the 5th plus 2? Direct substitution technically doesn't work because they don't. Real mathematicians, like when I say real, like professional mathematicians, don't consider infinity a number. It's more of a concept. Therefore, you can't really plug infinity in for something like that. You can't say infinity plus 1, even when you're trying to top your friend. Okay? So what you want to do, you replace it. So anyway, you can't just say 3 times infinity plus 1 over 4 times infinity to the 5th plus 2. You can't just substitute that in. But there are some principles that we can say, in general, I mean, if we're looking at numbers that are approaching infinity, which one of these is going to be bigger, the numerator or the denominator? The denominator, because if I have 100 million, billion, trillion, whatever, to the 5th times 4 plus 2, that is definitely going to be bigger than 3 times 100 million, billion. Okay? So I'm multiplying, all right? So in this case, the denominator gets really large. The denominator wins, so to speak. And if you have a situation where the denominator is growing faster than the numerator is growing, okay, then you have a situation where this is going to approach 0. Roger, you seem sort of skeptical on that one. I'm going to give you 3 divisions, and you're going to be a believer in me, okay? All right. So I want you to figure out what 2 divided by 10 is, 3 divided by 100, and 4 divided by 1,000. So 2 over 10?
0.2. The second one is 0.03, and the last one is 0.04.
Mm-hmm. Now, is the numerator growing?
Yes.
Yeah. Is the denominator growing? Yeah. Which one's growing faster? Which one, numerator or denominator, which one's growing faster? The denominator's growing faster, okay? So, and I'm looking, what do these numbers seem to be approaching? 0.2, 0.03, 0.004, it's approaching 0. Is it ever going to go negative? Oh, this is good talk here, because if I've got a negative over here, okay, and that means either that numerator or that denominator is going to be negative. Would you agree with that? Yeah. Okay, so I can't, now, I'm telling you these guys are both growing. So that means that this guy is going to have to stay positive, and this guy is going to have to stay positive. Since I'm growing 2, 3, 4, 5, 6, 8. So this numerator is staying positive, denominator is staying positive, so we've got positive, positive. This number over here is always going to be positive. So, but we can see that it's definitely getting closer and closer to 0. Okay? So, that's one of the 3 rules of growth. And that is, if the denominator is growing faster than the numerator, then the limit is approaching 0.
So what does all this help me solve?
Well, I mean, that one's going to help you solve part A. The limit of f of x as x approaches infinity is 0. Okay? So that's the part A. The limit does not exist and is neither for x. So I'm not sure if you put a dot right there. It says select the correct choice below and consider filling the entry. So then for part B, we need to figure out what's happening as x approaches negative infinity. And we're also going to do that. Let me hold off on that and tell you, I said that's one of 3 rules. Let me tell you the other 2. So this limit as x approaches infinity of, I'll say, f of x over g of x. So rule number one, if the denominator, can I just put wins? Which means it's growing faster. You're on the ball there? I'm in the frame?
Yeah.
More importantly, is this in the frame?
Yeah.
Yeah, that's what we really want to see. Right, does that make sense? When I say the denominator wins, that means the denominator is growing faster. It's getting larger faster. We saw that the limit then approaches 0. If the numerator wins, that is, if the numerator is growing faster, anybody remember?
Infinity or negative infinity?
Yeah, infinity or negative infinity. So I'll put plus or minus infinity. It sort of depends on the situation. Okay? And then there's a situation, what if they tie?
And it's just
It's such
Isn't it a fraction of the coefficient?
It is a fraction of the coefficient. Then it is a fraction of, technically it's the leading coefficient. An example of this might be the limit as x approaches infinity of 3x to the 4th plus 2x over 5x to the 4th plus 7x. So one thing that I didn't mention but sort of goes before all of this, when I'm looking at this numerator, 3x to the 4th versus 2x, that what you always want to do is you want to look at the strongest guy in the room, okay? That's what you're trying to figure out first. All that other stuff doesn't matter. The strongest guy in the room up here is this term right here, the 3x to the 4th. That's the one that's going to dominate this whole numerator. All right? As we get up into the quintillions, okay, the 2x isn't going to matter, but 5 quintillion times 5 quintillion times 5 quintillion times 5 quintillion, then times 3, this is really what's going to matter in that thing, okay? So I can almost just ignore that other part right here. The same thing for the denominator. I'm looking at the one that's going to have the highest power of x, the term that has highest power of x. That's the 500-pound gorilla, strongest man in the room. That's the one that I'm looking at, okay? So I've got 3x to the 4th over 5x to the 4th. I've got an x to the 4th in both cases. That's gonna essentially be a tie, okay? Because this number is gonna be growing large, this number. And so what happens is that we're looking at those leading coefficients, it's gonna be 3 over 5. Okay? So there, I apologize, I'm kind of working my way backwards, telling you other things that I was there kind of pre-calculus concepts in order to get to that. But those are some of the things that you need to know in order to get this one done. Okay? There's also the situation of how to deal with the negatives, okay, which we will address on Friday when we pick this back up. Okay? And we're not quite finished with that problem yet because of it. Okay. Thanks for playing.